welcome to Insight.Tech Talk, where we explore the latest technology trends and innovations. As always, I'm your host, Christina Cardoza, Editorial Director of Insight.Tech, and today we're going to be talking about the smart grid of the future. And we have a panel of expert guests from Advantech, Capgemini, CCS Insight, Enedis, and Schneider Electric. But first, I would love to get to know more about our guests and what they're doing in this space. Paul from Advantech, I'll start with you. What can you tell us about the company and what you guys are doing in the energy space?
So firstly, my name is Paul O'Shaughnessy. I'm the sales director for Northern Europe and the sector head for energy and utilities in Europe for Advantech. A little bit about Advantech first. We're a Taiwanese headquartered company established in 1983. We're a leading IPC market share company. We service a lot of industries. Energy and utilities is one of those sectors. It's primarily my focus. And we have 3 manufacturing plants globally in Japan, China, and Taiwan, and looking to expand on that. What we do in the energy sector today is, and what we would be known for, is basically a combination of fan and fanless systems that are used in primary and secondary substations for centralized protection and control. And we would also be a kind of a domain leader in that hardware in terms of the development of that hardware for the future, for the next trends in terms of digitalizing the grid. The other areas that we've been involved in has been in the connectivity, secure connectivity to remote assets on the grid. And that's something I'll talk to a little later as we go through the podcast. The big change for us right now is that we're realigning the business to become vertically focused rather than regionally focused. So it's very significant focus from headquarters and a drive to focus on energy and utilities.
Great. Looking forward to digging in a little bit more about what that means for the future and for the grid. But next, I will start with Felipe from Capgemini. Tell us a little bit more about yourself and what Capgemini is doing in this space.
Hello, everyone. So Philippe Vier, Energy, Transition and Utilities Capgemini advisor. I was the former head of the Energy, Transition and Utilities sector within the company. I am participating in many projects about grid modernization, which is definitely one of the key offer of the company. The company covering consulting, engineering, and application services, plus insight and data, intelligent industry, and many other offers over 50 countries in the world. And we see a significant growth in grid modernization these days.
Thank you, Felipe. Ian, I'll throw it to you next. CCS Insight just published a paper on this very topic with contributions from various different guests on the podcast today. The Grid of the Future, it's available on Insight.Tech. So we'll dig into some of that. But before we get into that, what can you tell us about what you're doing at CCS Insight? And if there's anything you can tease up about that report we have.
So, Fogg, I'm a research director at CCS Insight. We're an industry analyst company that looks at technology transformation across a number of different areas. For this piece, we looked a lot about what's happening with the grid and talked to many of the people on this podcast and many other companies as well. We also looked at what the parallels are with other sectors, with digitization in other industries, and what the implications are for the grid of the future from those wider perspectives.
Awesome. I love that so far. We've had, we have an analyst, we have hardware, we have software, we have, a lot of people from different spaces in this area. So I think it's going to be a great conversation. And then, also joining us, we have Marc from Enedis. So what can you tell us about what Enedis does and where you see the future of the grid going?
Hello, I am Marc Delandre from Enedis. I am director for Advanced Network Technologies within Enedis. Enedis is a main French DSO and probably one of the largest in the world. Enedis is a full subsidiary of EDF. We are operating the medium and low voltage network in France. It means over than 1.4 million kilometers, 800,000 secondary substations, and almost 40 million customers. And we have to face on a daily basis with more and more renewables and charging points connected to the grid. And it's a big challenge for us for the coming months and years.
Yeah, I expect renewables to be a big part of this conversation that we'll get into. But before we get there, last but not least, and I did the introductions by company alphabetical order. So, that's the only reason why we kept Valerie last, but we saved the best from last. Valerie from Schneider Electric. What can you tell us about what you do in this space and Schneider?
Yeah, sure. Hi, everyone. So very happy to be here today with all of you. I'm Valérie Laillant. I'm the Vice President in charge of what we call Power and Grid segment in Europe. So this is all the chain of energy from the power generation, transmission, distribution, down to what we call the prosumer. Schneider Electric is really the leader and the specialist in energy management and industrial automation. So we do everything we can to help our customer get their infrastructure more resilient, more efficient, and more sustainable. And we accompany them with what we call EcoStructure, which is IoT architecture from the connected product up to software analytics layers to really make their network smarter.
That's great. And that's sort of where I want to start the conversation off today with you, Valerie. You just mentioned you're helping customers be more resilient, efficient, sustainable. So since you're working with all of these different customers, and I imagine they're in various states of their transformations or ability to innovate, what would you say is the current state of the grid and our efforts to make it smarter?
I would say that the grid is not smart enough today and requires much more digitization to make it more efficient, as I mentioned, but also flexible and decarbonize. So for that, we have some standard like IEC 61852 that is contributing to basically make it more standardized in terms of a substation, what we can do. But we will need the 61850.3 to really make it even more efficient with the start of virtualization. The root cause of all this need, I want to do a kind of step back. Why do we need the grid to be smarter or more digital? It's really coming from the pressure at the EU level to have a better mix of renewable. And we have to grow from 23% of renewable in the mix in 22 to 42.5. And actually, the nice aim is even 45 by 2030. Which means it's put a lot of pressure onto the grid to integrate this renewable. And this is happening at the edge. And we cannot anymore imagine to invest in a lot of hardware and CapEx to absorb that capacity, both on this generation side and on the demand side, because I don't even speak about the demand for more electrification, EV, etc. We all know this pressure on the demand side. So we need to make the grid more digitized and smarter to not only count on the CapEx, which usually is taking 5 years as a project, but to make it more efficient by putting extra software to make it smarter. So for example, if we implement or deploy a ADMS solution, we know we can reduce at bare minimum the technical losses by 1 point, which means basically having it more efficient, more resilient. And we know, for example, we have the case with Enel in Italy, where when we deploy inside, they were saving up to 10 million euros per year on investment that they saved basically by putting that. So this is key, this digitization, and the journey is long, and we are not yet there. So we are really, pushing all the ecosystem to make sure that we actually invest on the software. And just one last point of reference, usually when we invest $1 or €1 on renewable, we should invest the same on grid. And actually, it's more 1 on renewable for 0.75 on grid. So we see that there is a requirement to invest more on the grid.
I always love when we talk about these transformations being a journey, because it is a journey and it's not a cookie cutter approach either. Companies and everybody may be in different parts of the journey and they may need different things as part of their journey. So we're going to dive into a lot of these different journeys and how we can successfully do that. But I'm curious, before we get there, Ian, with the Smart Grid report that CCS Insight did, are you seeing some of the similar things about where we are with the grid and the transformations as Valerie and Schneider's outlook is?
Well, obviously, on the generation side, there's been a massive shift to renewables, and we have comparison of 2010 and 2023 in the report with some figures across 48 markets. I mean, the interesting piece there is when you look at where the growth has come from within renewables, if you look at sort of hydro, wind, and solar, it's come from solar and wind, which have very different patterns of generation, which I think leads to what Valerie is saying about why you need to also invest in the grid alongside the renewable side. I think the other piece that's interesting is it's not just which I think one of the speakers just touched on, is it's not just the shift within the electricity generation industry to renewables. As the wider economy decarbonizes, that shifts a greater proportion of the overall energy needs of each country to electricity as well. And that has another dynamic. And then on the consumption side or the distribution side, you have not just new consumption with things like EVs, you've also got generation happening with solar panels, which can make that potentially a two-way dynamic, which is quite different to what that distribution grid used to do. And then you think about, well, how do you balance the consumption with the generation? And you can obviously look at storage solutions, but one other way is having greater intelligence in the grid to encourage people to shift the consumption pattern across hours of the day. And there you need very, very good, very speedy data communication between the different parts of the grid, right the way from the users, right the way through the distribution, to help you balance that need. And that requires new investment in technology, in substations, in billing systems, in all kinds of parts of the grid.
Yeah, and I think the changes can be so complicated and confusing sometimes. I typically think the best way to be successful and for it to be able to scale and to be broad across, different countries like you were mentioning. But like you mentioned, different countries need different things. And I think almost everybody on this podcast, we're all in different places throughout the world. So I want to look at some of the factors that are pointing to the smart grid that are driving this effort. Felipe from Capgemini, can you tell us a little bit about what you're seeing and what the demand or pressure is from Capgemini?
Absolutely, Christina. And I will build on Valerie and Ian's points, definitely. First of all, renewables are intermittent, which means that some hours of the day you have too much generation compared to the consumption, and some hours of the day you have not enough generation compared to the consumption. So we need to definitely balance, and there is a lot of pressure on the electric system and on the electric grids for this production equals consumption balance, and the Kirchhoff law, definitely. This overcapacity some periods of the day will make the markets with many negative episodes, negative prices episodes that are endangering the energy transition, because it's endangering the profitability of generation players, amongst which renewables players. Secondly, there is a paradigm shift, because in the past, the energy sources were centralized, and the electricity were flowing through transmission and distribution grids from the centralized generation assets. Today, the renewables are distributed in the grid, and it makes a paradigm shift from one way to two ways electricity flow. Then we have the massive electrification. We are today at 23% of electrification compared to the energy needs, and we will move probably from the net zero scenario from the International Energy Agency, to about 50% or 60%, depending on the region of the world. Meaning that we have EV charging, we have electric heatings for industry and for buildings and residential customers. We have hydrogen production. We have data center, which accounts today for 2% of the electricity, and which will account for 4% of electricity. Very strange. Today, the consumption of data center equals the production of France. It's a significant country. We have also hydrogen production. We have also storage, which is coming. Then the other drivers are about the digital technology, which have progressed a lot. the convergence between IT and OT, the AI, Gen AI tomorrow, automation can be leveraged to avoid physical investments on networks. As Valerie has stated, anytime you put $1 on renewables, you need to put $1 on grids, and it will mean that we will move from $400 billion on grid investment today to $700 billion by the end of the decade, by 2030. It's a huge increase in the investment, and it will increase the price of the electricity, of course.
Yeah, a lot going on driving these efforts, and a lot that we still need to address and begin to even make dents in. Marc, from Enedis' standpoint, because you guys sort of are coming in and you're part of this conversation and the innovations of the grid from a different perspective. So are you feeling those same drivers and factors, and what pressures do you feel from your end?
I fully agree with what have been said by Valerie, Jan, Paul, and Philippe. Electricity is magic. You can do almost everything with electricity. You can do heating, air conditioning, lighting, cooking. You can use electricity for a car, for trains, and so on. Electricity can be generated by big units, nuclear plants, by solar panels, by wind farm, and so on. But there is a big issue with electricity. It's not impossible, but very difficult to store electricity. We have the experience of electric cars, and the main issue with electric cars is the range of the cars, the sizing of the batteries. So the challenge we have to deal is to balance in real time energy consumption and generation. And it has to be done at the level of the primary substation, at the level of the secondary substation, and by any customer connected to the grid. And to do that, we need tools. We need the tools developed with our partners. And the main issue we have is that an electric grid is not an entity inside a building. It's covering a big country. So we have many units in the field. So when we invest a huge amount of money. So it has to be affordable by the customer, because at the end, the customer will pay all the investment on the bill. But we need to have a solution we can operate for years, for a long time. So we will discuss about standardization, open standard, about also cyber security and so on, to manage all this in the long term.
It's interesting because when I hear the term smart grid or think of the grid being smart, I think of edge AI and automation and all of these different digital tools and technologies we've been talking about. But we also have to be smart in the ways that we approach the grid, which has become very clear just from the beginning of this conversation. And of course, edge AI and all this technology is part of it, but it's not the reason to be becoming smart and to be doing this. So I want to lay out what the main pillars are for this grid of the future to really be successful, because we talked about resiliency, efficiency, sustainability, flexibility, having a right balance. So Ian, is there anything that you can share with us about what this all means as we move towards the future of the grid and what those real pillars we should be looking at are?
Well, I think to highlight some of the challenges. I mean, one of the other challenges when you look at, say, EV adoption is often it's not spread evenly. So you get areas of the grid that have greater pressure from some of these changes than others. I think the bigger challenge, though, when you think about the grid of the future and you think about making it smarter, is what we need to do is to increase the flexibility of the system so it can respond to these different consumption and generation patterns. But we must also maintain the reliability of the grid at the same time. It's not acceptable for the grid to become as unreliable as a cellular network. It has to maintain the reliability while also adding increased flexibility. And that has very specific challenges when you start looking at the technology that needs to be deployed to improve that responsiveness, to improve that flexibility, but still keep up the reliability.
That's great. And Paul, in the beginning of your introduction, you mentioned how Advantech, you guys focus on hardware. And so I'm sure there's a lot of pressures coming in just looking at that and making sure that you have all the hardware and technology in place. So as Ian's talking about some of the challenges, I want to hear from your perspective. What are the limitations that you face from a hardware perspective in making this possible?
Yeah, that's a good point. Advantech has a massive portfolio of product. The issue is, have we got the right product? And that's the real question when you start to talk about some of the challenges and some of the considerations we need to take into account here as a hardware manufacturer. For me, one of the major challenges when I look at this, and I listen to Philippe and I listen to Marc and Valerie talk about, and Ian talk about what's going on and the scale of it. It's the scale of the challenge that, from a hardware perspective, is a great thing, of course, but it's also a huge challenge for all of us to try and cope with. The other aspect that we need to look at as a hardware manufacturer, and indeed the end users and the SIs and all the other ecosystem that are deploying the technology, is the variability of those assets that are deployed. It's not like it's a standard asset. There is a huge variability. And that variability requires multiple solutions. And if you think about the E4S Alliance, for instance, where I think all of us are members, we have 13 use cases in that alone within the E4S working groups that we have to try and make sure we can service with an open platform. So getting that information about the volume and the variability and the definition. So the hardware definition for us is the big challenge. Clearly defining what that is. And that's driven by the use case and the type of assets in the application. And we have to consider things like, we're a hardware manufacturer, but we have to consider that we need to be able to support various softwares. We have to be able to support legacy protocols and all of the new protocols that are required. Is it real-time deterministic system, virtualization, security? These are all key topics. Security has a hardware element with TPM. Is that something that's going to be required? And then working with partners, strategic technology partners like Intel, who are a significant partner for us, on defining the processor roadmaps that we need to be focused on to leverage that to ensure we're bringing the right products to market. Storage technology, I/O, cooling. All of these are key things that are driven by the variability of the assets in the field and the scale of them. But also there's one other big thing, and Valerie alluded to it earlier, which was about compliance to things like 61850-3 and IEEE 1613. And so as a hardware manufacturer, these are things we have to comply to be a player in this space. And that is not an inexpensive topic to discuss. It's a real challenge, particularly if the definition of the product is not really fixed. It can become a very expensive thing to deal with.
Yeah, it is quite intimidating, this journey. You're talking about the technological challenges, it's cultural challenges, and then you have all the pressures from needing more electricity, electrical vehicles, different regulations. And, it's one of those changes and transformations that we can't ignore. Everybody has to be moving towards this. It's not that you can continue to do things the way that we've been doing it. So it's great to hear that you guys have all teamed up with the E4S Alliance, making sure that we approach this in the right way, that we standardize how we're going to move so that we can start addressing and partnering together with all of these challenges and limitations. And I'm sure there's more challenges that we haven't even crossed yet.
The challenges are many. The money, because you have to increase your investment in digital grid and in the grid itself. And the investment approval should be made by stakeholders, shareholders, but also governments and regulators, to probably doubling in 2030 the investments that were made in 2020. Second challenge, the skills scarcity. Smart grid will create probably in the next 20 years 5 million of jobs with the digital technology at the core. And there is also the move from electrotechnics to digital. And there is also the baby boomers, the retirement wave, and many people to replace. The lack of roadmaps. Many utilities are launching one program, the second program, but you need to have a consistent roadmap and to revise it every 2 or 3 years because things are moving very fast. The permitting, when you are building new lines, there is a digital content about permitting, and it can take 1 to 6 years in main geography to build a new line. And digital engineering is very useful in that direction. And of course, people don't want electric lines in their backyard. Same then for windmills or renewables. And finally, there is also the lack of standards. Valerie has mentioned the substation standard, and we need, and this is the purpose of E4S or VPAC, depending on the granularity of substation, to agree, all of us, technology providers and grid operators, on common standards to develop interoperable objects, interoperable modules on smart grid. Each limitation goes with many solutions that can vary from one country to another, from one electric grid state to another. So, big program, a need for roadmap, and many challenges to overcome.
One thing I want to touch on that all of you have spoken about is the idea of renewable energy sources providing clean energy to the grid in an effort to help it become more sustainable, resilient, and that overall efficiency that we keep talking about. But of course, renewable energy sources, they also come with their own considerations and challenges when approaching the grid. So Ian, I know this was touched upon in that grid of the future report from CCS Insight. What are the considerations and how should we be thinking about renewable energy sources when we are moving towards a smarter grid?
I think, as I said, storing energy is very difficult. So if you can alter the consumption patterns to better respond and reflect the more variable generation patterns that you get with solar or wind, you don't need to have as much generation capacity. And that's why that substation piece is so important, because you put intelligence there, you can help match things up. One of the examples that we've seen is the nature of electricity tariffs is changing. In some consumer spaces, we're seeing half-hourly price points and sometimes even more. And that requires very precise timing, very good technology at the end user, but also in the substation and right the way through. And what's driving that, a lot of that is this shift to renewables. I think we saw between 2010 and 2013 across 48 countries, the proportion of electricity generation that was wind rise from 2.6% to 10.8%. Solar, similar rise from under 1% up to 6.6%. So very significant increase in those. Obviously, solar is seasonal in terms of time of year. The further you are from the equator, you get big winter-summer differences. Wind obviously varies based on the weather. We've got to have that greater flexibility, and that requires greater communication within the grid, technology systems that are able to marry this thing up.
I'm just curious, since Enedis is managing, electricity distribution networks, and we talked about renewable energy. How do you guys approach renewable energy, or what is the role in some of your efforts renewable energy is taking?
We have to deal with renewable, and tomorrow every customer will become a prosumer. So it means you will have renewable energy for each single dwelling house on the top of any building, everywhere. And the key role of the network will be to balance energy generation and consumption. It will be our core activity tomorrow. So it's strategic because without electricity, you cannot do everything. It's strategic because it's very important for everyone, and it needs a strong investment.
Yeah, and the great thing is that there have been so many advancements in technology to help get us closer to our goals. It's funny, we've been talking about moving towards a smart grid for years, probably decades now. And what has changed during this conversation is technology has advanced to help us reach some of these goals. So I want to look at some of those recent technological advancements and how they can help. And then we'll get into, later down the conversation, how you can successfully adopt those new technologies. So Valerie, I'll start with you from Schneider's perspective. What can you tell us about new technology in this space that is helping us go towards a smart grid?
So new is maybe not new, but new for grid, I would say, because there is a maturity in other segments like telco, health, transportation that have been using some of this technology prior to the grid. And this is good because we will leverage a kind of mature technology into make our grid smarter. So first of all, there is a evolution of ADMS solution to really make what we say we want to have a grid that is more efficient and more resilient. So we have a capacity management, outage management, load and generation control, asset management, power quality that are really here building the reliability of this network and this efficiency. There is also the need, we mentioned a lot, the renewable and the prosumer. For me, there are two things. There is a generation, but there is a prosumer. Prosumer is very interesting in the scheme of flexibility at the edge, because this industry or this commercial building, even potentially consumer, that have their own generation. I mean, typically, solar rooftop can be an example, but in a bigger prosumer industrial area, port, for example, they could have actually wind as a generation. And then they are going to potentially re-inject, resell that capacity to the grid depending on the price at a certain time versus storage, etc. So we have now a solution to integrate this flexibility at the edge. And these are things we see in the evolution to make the grid more efficient and also to monetize that ecosystem. The second technology, which is not new, but that we are also bringing into grid, is digital twin, which can be used for training, for simulation, for remote software update, typically also for managing the IED firmware as a fleet to upgrade them at a certain point of time altogether. So we mentioned compliance. So we have IEC 61850-2 that is helping in terms of security, cyber security, openness. It's a first level of standardization that can help at the substation level. And the third point is with all this data at the edge, putting pressure on the substation, virtualization is a key. And this is why we are all in E4S, because we believe that this virtualization will absorb the level of data that is coming and the pressure that is coming at the edge on the secondary substation. We have the experience from other market, to name one, telecom at least. And 61850-3 is under definition. And also in E4S, we really want to collaborate to define open standard, reference architecture, and common design towards this virtualized substation. So I think we have a mix of mature technology coming from other end market, plus our own, I would say, like ADMS technology that is evolving to take into account, for example, flexibility or virtualization.
So in some of the research, the Grid of the Future, you talked about what businesses can learn from other transformations happening in other industries. So is there anything from that report that you can share with us?
So I think virtualization is one of the key ones, where in many industries we've seen them move ahead with virtualization, shift more functions from hardware into software, use standardized hardware solutions which give you scalability to upgrade the platform to support higher performance workloads. We've seen that in many different industries. I think the other piece that we've seen in other sectors is this combination of operation technology and IT and how OT and IT interact. We've seen that, and there's some examples in the report around that too, around what that interaction is and what the different cultures are around that. And that's something where there are other industries which are going through exactly that same kind of transformation.
It's good to hear that we have some of this technology from different industries or technology becoming more mature that is going to help us make these changes. I think digital twinning is very powerful, being able to make that digital representation and see how changes are made before they're actually implemented. And so from your perspective, what other advancements or what other technology do you see being used in these efforts?
So I will take different angles because I agree with everything Valerie has mentioned. Definitely, I will take the angle of automation. For example, we are dreaming of a control room without people, only for critical conditions, but fully automated. We are dreaming of AI enabling self-healing when there is an outage to reconnect the consumers, 99 of the consumers, in 1 or 2 minutes. We are dreaming of predictive maintenance, as Paul stated earlier. We are dreaming of all the AI capabilities, and many utilities are deploying AI at scales with 20, 30 use cases, which are really beneficial for the grid performance and for avoiding investment. For example, digital dynamic line rating to go with more electricity than the nominal capacity of the line. We are dreaming of asset investment lifecycle planning. It starts with asset AI-enabled grid planning. Then you can follow the full cycle of construction up to the deconstruction of the line or of the nodes of the network, the transformers. So many technologies can be enabled today to bring value to the grid operators and finally to the consumers.
Great. And, the automation, the data, like you all mentioned, I think it's also going to be extremely important getting real-time analytics and all of this information so that we can make changes on the fly, or we can really get like these deep insights. So all you were mentioning, the edge and AI. So Paul, I know this is something that you also brought up in the beginning. What is the role going to be of edge and AI? Because this has been a big conversation in all different industries. So how is edge AI coming into the energy and the utility space?
I think, if I talk about it from our business perspective, this is the fastest growing part of the business burn-up. It is absolutely exploding, and the number of use cases and applications are growing day by day. Up until now, it has been heavily dominated by vision-based applications. We have seen so much of that. But I think to something that Philippe mentioned, which is about real-time monitoring and control, that is something where Edge AI has a real opportunity to have massive impact on the grid in terms of real-time decision-making at the node, at the substation, allowing for immediate responses to change grid conditions and improving the stability and reducing downtime. The other one was predictive maintenance. We see this already heavily deployed in manufacturing environments, where by analyzing the data from existing sensor networks and overlay sensor networks that are being deployed, where you have that IT-OT conflict, where rather than trying to fix something that isn't broken, you overlay a new network and put that in place. We've seen a lot of that happening, and has a huge impact in terms of the utilization of Edge AI in optimizing the efficiency of manufacturing environments. I see no reason why the same thing can't apply in the grid. The other one, and the topic that comes up probably as the most talked about topic within the IoT sector in general, is security. And I think AI has a real opportunity here, and AI on the edge has a real opportunity in terms of enhancing the security already in place, both from a cybersecurity perspective, but also from a physical security and from a health and safety perspective. I said at the start that we've seen an explosion in the area of vision, And what we see is a lot of vision applications for Edge AI, where it is protecting workers in dangerous environments and ensuring that the people who are getting access to certain environments are the people qualified to access them. And I think that is something that has an absolute play for the grid. And then, as I said, with the cybersecurity part, being able to monitor behavior and identify unusual behavior at the point on the node is a critical aspect of cybersecurity and enhancing that with Edge AI. They would be the three main areas that, as a manufacturer, that we see real opportunity for deployment into the grid.
You bring up some great points. As we are adding all of these digital technologies and advancements to the grid, we have to make sure that, the theme of the conversation, the reliability, the sustainability, the efficiency, we have to make sure that it's secure so that it could be able to do all of these different things. One thing you mentioned, and you all mentioned, is, like AI is going to be really good at the substation. A lot of these changes are going to be really good at the substation. And it's funny, when we first had this conversation years ago about the smart grid, the substation was the best place or the first place to start making these changes. And so we're still having conversations around changes at the substation. So I wanted to understand, what is happening at the substation? Is this still the best place to make these changes or to start some of these efforts? Or have we moved beyond the substation and focusing on different areas?
I would say the substation is still alive. It's true that some of the offers, like the one we mentioned before, asset performance management for predictive maintenance, digital twin, ADMS, DERMS, all at enterprise level, like any control center, SCADA, etc. However, as I also mentioned, the need to integrate renewable farms and prosumer is happening at the edge. And the flexibility needs to happen at the edge. So for us, the secondary substation is alive, but has to adapt to the new challenge. And basically, virtualization is a part of the answer. So yes, there is a future for the secondary substation, really due to the pressure that will happen at the edge, both in terms of connection and data.
I fully agree. We need real-time monitoring and control. We need edge computing, virtualization, and so on. Cybersecurity is a key point. I would add we need also evolving solution. We don't know today what will be the priority use cases at the secondary substation in 5 or 10 years. So we need evolving solutions based on open standards. Why open standards? Because big DSOs such as Enedis cannot rely on any proprietary solution, even if it is a very good one. We have to be able to mix in the field solution. When I say solution, it means hardware, software coming from different providers. So it means certification, it means interoperability, and this has to be defined within E4S organization.
So I think that the substation keeps coming up as a critical point, and that's because it's that focal point for local distribution, for data gathering, local control and protection. And I think the other piece here is that piece of how do we build them? How do we upgrade those to give us longevity? When we think about AI, which is becoming this incredibly important thing now, if we'd been having this conversation 8 years ago, we probably wouldn't have been talking about AI. And in the time scale of a grid, 8 years is actually not that long. When we look at the technology we're putting in, the open interfaces that Marc referred to are very important to give us that longevity, give us that ability to continue to upgrade. Virtualization also gives us capabilities, because as you put functions into software, what we've seen in other industries is that makes the innovation cycle easier. It gives you a longer runway of innovation that you can upgrade the underlying hardware and upgrade the software functions kind of separately if you need to. And that, I think, is really important for that longevity and that ability that we need to respond to changing consumption and demand patterns.
That's a great point, and it just highlights the need to future-proof what we were talking about 8 years ago, AI wasn't really on our radar. Some of these technologies weren't on our radar. So to Marc and Ian, everyone's point,
if it was on the radar, we'd call it machine learning. We wouldn't have called it AI. And certainly Gen AI wasn't on anyone's radar.
So this need for future-proofing is even, more important. I want to hear from Paul from a hardware perspective, because it makes it very difficult for someone like Advantech to be able to keep up with all of these changes, to know what changes to bring in, and to allow your customers to be able to take advantage of these changes without having to go through all new investments. So I'm curious, how can companies future-proof? How is Advantech helping with future-proofing efforts when we are talking about the grid of the future?
Well, I think if you kind of step back from it a little bit from our just purely hardware perspective, and to some of the points that have already been raised, being a member of the E4S, being a member of VPAC and the 450 megahertz Alliance and all these alliances, the one thing that's really clear is the only way we can achieve what we need to achieve as an ecosystem, and future-proofing what we need to do, is through modular and scalable architecture. So design systems with modular components that can be easily swapped out for other and replaced. This allows for incremental change that you need to make to keep your systems up to speed in terms of where they need to be. Standardization and interoperability. I guess for manufacturers like Advantech, this is becoming more and more of a thing that we need to deal with, because given the scale of the challenge that's in front of the grid right now, and Marc alluded to it, they can't work with proprietary technology. It has to be open because it has to be multi-vendor, and we totally get that. So standardization and interoperability, allowing the open standards and protocols that are required to be supported, and compatibility between different devices and systems is going to be key to future-proofing. And I think there's another piece that's really important to this, and that's because it is the top topic, is robust cybersecurity measures. Implement strong cybersecurity practices at the front end to protect against evolving threats. And this includes, regular updates, threat detection, and response mechanisms, of which Edge AI should be something that can certainly help in driving that. But then coming back to it as a manufacturer and our perspective, one of the things that's often overlooked when we talk to customers and they talk about a particular platform that they want to use, and they've defined it and they've benchmarked it and whatever, and that's got to do with component selection and hardware lifecycle management. Before committing to the design, we need to complete lifecycle audits on the key technology components to ensure the longevity is built in there. So Advantech, working with strategic partners like Intel, where they actively promote their roadmaps with us and make sure that we are aware of the latest technologies that are form fit and capable of being deployed in this type of environment, is really critical, and is something that I think is overlooked a lot of the time when you talk about modular and scalable architecture. You also have to plan in at the front end of that some longevity. And the way to do that is to look at some of the key technologies in terms of lifecycle management.
Yeah, and it's a great point. Having that partnership and collaboration and working with the E4S Alliance is going to really be important to future-proofing. Nothing is going to restrict you faster than having that vendor lock-in. It's not going to be able to move to take advantage of some of the new changes, or it's going to be really expensive because then you're going to have to rework any investments that you've already made. So I wanted to touch a little bit on that, Paul, since you mentioned it. The importance of working in the E4S Alliance and working obviously with partners like Intel. I should mention Inside.Tech Talk and Inside.Tech as a whole. We are sponsored by Intel, but I think they do a lot of work to be able to have companies and have customers be able to move fast, take advantage of the changes happening, be able to take advantage of the latest and greatest changes while still being flexible and scalable. So can you talk a little bit more about the importance of those partnerships and collaboration?
Sure. I think, you mentioned vendor lock-in. I just want to go back to that point for a second. And of course, as hardware manufacturers, there's nothing better, right, than being locked in as a vendor, which is terrific. But the reality is the scale of this challenge and the scale of this opportunity requires so many vendors and so many moving parts that it has got to be an open architecture. And we totally get that. Coming back to the point that you asked me about in relation to partnerships and collaboration, we are working now along with everybody in this meeting with a couple of major alliances. The VPAC Alliance for virtualized protection, automation, and control in primary substations, and with the E4S Alliance for edge for substation. And those alliances and the collaboration that goes on within the various working groups, whether that's hardware, software, go-to-market, cybersecurity, whatever it is really important for all of us, for hardware manufacturers, for software vendors, for end users. And I think that whole ecosystem that sits within each of those alliances, it's an opportunity for all of us to learn from each other. And to understand what are the real requirements, because it's in that environment that the real requirements are discussed and that open architecture is being defined, so that for us as a hardware manufacturer, we understand what we need to be thinking about next. Even though the definition of what's coming out of E4S as a single scalable box to satisfy all of the use cases may not be the perfect answer for many applications. At least there's an abstraction between the software layer and the hardware layer that allows us to ensure that our hardware will perform in those applications given the definitions that have been laid out by the Alliance. And that's the critical part. Without the Alliance, without the collaboration, and without the direction from the end users, which is the DSOs in this case, it would be a tough job to achieve some of the things that need to be achieved.
I completely agree. Like we mentioned in the beginning, there's so many changes happening, so many places to make these changes, and so many different ways to come at it. Valerie mentioned it's a journey. So having these alliances, it's a great starting point. It's a great point to keep us on track and keep us in the same direction. It may not be a one-size-fits-all approach, but it is something to look at and to consider and to help us on this journey. And Valerie, your main themes throughout the conversation that we have been talking about is that resiliency, efficiency, sustainability, flexibility. So from your perspective, how are these partnerships and collaborators helping meet those goals and those pillars that Schneider has?
Yes, so of course, a lot was already said by Paul and Marc, and I also fully agree and support what they said. What I could add on top of what they said is that traditionally in energy management, energy infrastructure, and grid operation, it's an OT world. So what we master very well is OT knowledge. But here, when we speak at the challenge and the new technology that we need to deploy, that comes from IT. So it was very important to build this alliance with players like Intel, like Capgemini, that have a lot of IT knowledge to leverage the best of IT into our OT world and to make this IT and OT works together. And we know that it has been already leveraged in telco, in automotive, health, for example. So this is why I see a lot of value of the Alliance. Of course, Alliance purpose is to get open standard. We mentioned it before, not to be a slave of some proprietary protocols. So open standard, kind of reference architecture and design, and common use case, because this is very important also, to have a use case which are driven by the user, which is in that case DSO and represented by Marc today. But then the idea is to bring in that alliance the best of both from OT and IT and transform what used to be a very hardware play at the secondary substation into something that is going to be virtualized and that will leverage the benefit of the two worlds. So for sure, this collaboration is key. I think we are all here because we believe into that, and we have a nice journey in front of us.
So we've been talking a lot about the challenges and the technology and all of these different spaces. I want to give our listeners now, some customer examples or case studies, if we can, that really helps them paint a picture of how important these partnerships and working with companies like you all are in being able to make these ideas and these solutions a reality. So I want to turn it over to each of you if you have any customer examples that you can share of how you are helping reshape the grid and helping customers reshape their efforts. Valerie, I'll start with you on that one.
Yeah, sure. So I have some, generic example. I can not name all customers, of course, but I mentioned at the beginning our EcoStruxure architecture, or IoT architecture, which is really the way we envision the network and the network of the future with 3-layer connected product, edge control, and apps analytics software services layer. So we have been deploying this solution in some grid operation, and we know that we can really reduce the delivery time by more than 30% when having an integrated solution, rather than to have to configure at each node each of the hardware element, have a really enterprise level solution to manage the configuration of the network. So that's one of the value. I would say that overall also having an intelligent network is helping in the operation and maintenance part of the life cycle, which we have been able to see a kind of TCO, so TOTEX, CAPEX plus OPEX reduction by at least 15% by having some intelligent network that leverage predictive maintenance, asset performance management, etc. And really the last point I would like to take as an example is what we are doing on a very new approach, which we call LV grid management, because of course we mentioned the edge. So at the edge, what's happening is below MV there is LV, and it's becoming more and more an issue for the DSO because of all these consumers that want to connect back their production to the network. So LV grid management is really an end-to-end approach from the low-level sensor, the feeder, the protection and the control at the substation up to the ADMS. And we are piloting this with Unarity. We will announce a bit more details during Enedis about that. So yes, this kind of solution, we have started implementing it. And we see the value both in terms of CAPEX optimization and OPEX optimization and end-to-end management of a challenge that we see coming with these evolutions.
Great. Looking forward to some of the news you alluded to that you will be announcing, in the near future. Felipe, I'm going to turn it to you next. Any customer examples you can share with us of Capgemini?
So we are working for many leading transmission and distribution grid operators on their smart grid journey. There is no one smart grid journey for every player, but various priorities. We are starting with the roadmap. It's a consulting engagement, and typically with, of course, technology skills, IT and OT, because we are also in engineering and IT integration. Each of them are launching, the larger players, a smart grid program which will last 10 to 20 years, probably, with various priorities and various domains. I will not repeat the domains I was mentioning earlier. But definitely, it's not one program. It's a collection of large projects. Project to replace a control room, a project to automate something, a project to make a substation smart and virtualized, these kind of things. And even when we are going to the network instrumentation, the smart substation, we see that the use cases are not the same. Of course, we have a common core of use cases, but some utilities are focusing for some substations on these use cases and for some other use cases for some other substations. So definitely many examples, replacing the control room, instrumenting the network, the smart substation with the E4S and the VPAC alliances, real-time health asset management, digital twinning, digital engineering, when you have to build thousands of kilometers of new lines, which has not happened in the developed world since a long time. Digital engineering is definitely something very valuable. Asset investment lifecycle planning, performance management. So many dimensions. I will not drop the names. There is only one I can tell. It's Enedis, for which we are working on many dimensions, notably on data and on substation with Marc. But definitely a different roadmap for each of them, and a need to collaborate. I insist on that. And so on a common standard with an ecosystem of partners we are all part of these days.
Great. And since you mentioned Enedis and Marc, I'll turn the question to Marc next, but switch it up a little bit. How are you working with these partners to make some of the changes, or what is Enedis doing in this space? How is their journey to the smart grid look?
First of all, I would like to add some comment after what Philippe said. You have many utilities in the world. Enedis is one of the largest, but we represent only 2 or 3% of the total market. So the market is huge. All the utilities are facing the same problem. Strong investment for electrification, renewables, charging point for electric vehicles, and so on. Even if each utility has its own roadmap, but the target is more or less the same. So we have the same problems. We have to work together to build a common solution. Common solution within E4S with Schneider, Capgemini, and Advantech, and so on. We have big players within E4S, and we have all the knowledge to build the right solution for the market. And we have to work together on it. Enedis, for sure, is not a technology supplier. We are a customer, but we know perfectly, or almost perfectly, the problem on the grid, how to manage the grid. So I think all together, with IT, Capgemini, and so on, all the partners, we are able to define the best solution for the coming years.
Great. And Paul, what can you tell us about how you're helping customers, how you help customers like Enedis, or any other examples you may have to share?
Yeah, maybe I'll take a more specific story that I can share with you. It's been mentioned quite a few times in this discussion about digital twins, and we had a customer, a distribution operator, who had a resilience issue in terms of communication and connectivity in their to their remote assets, and they had 3 primary issues to deal with. One was the geography itself, one was environmental, and the other was geopolitical. So they had some significant challenges in terms of cybersecurity, and then the weather and the terrain. And we worked with a partner and that DNO to come up with a solution that would allow them to use one of our platforms, our software platforms for device management, which uses digital twin modeling to ensure that those devices that are being deployed on the assets were secure, and that the only way any changes could be made in any way was from the network operations center. And that was something that we developed over, basically a 2-year period with them, and rolled out to 5,000 assets. And just to put it in perspective, this is something that started pre-COVID. And so when we talk about some of these applications like digital twins, they sound like they're really sophisticated things, but they can be quite simple in terms of modeling the piece of hardware or the application that needs to run on that particular piece of hardware. And again, when we talk about things and the way things change, and we're now talking about virtualization, back then the topic wasn't virtualization, the topic was containerization. Containerization to help improve the security on the hardware. So those are areas that we've worked with in the past. And today we continue to work within the alliances, obviously, to ensure that we are an active participant in the various working groups to ensure that our hardware and whatever solutions that we bring to market with the other ecosystem members in the alliances is meets the standard required for the DSOs.
One of the things that comes up, and I think we talked about the importance of the communication of data backwards and forwards. And one of them that we have been involved with is around smart metering and around the cellular capability, because often smart meters use cellular technology to communicate data. The problem with that, there's two problems. One is it's often not that up-to-date data. It's 15 to 60 minutes. Often the data is spread, which if you've got short spot pricing and you're trying to do very smart tariffs, isn't always quick enough. But the other piece is it's a hardware solution rather than a virtualized software-defined solution, which means that there are challenges now with older smart meters that have older cellular radios for network generations that the mobile operators want to switch off. And that speaks the different pace, the different life cycle of that part of the economy with the smart grid. And of course, having those smart meters is foundational for many of the usage scenarios of shifting consumption patterns. And if we're having to start upgrading and replacing those early smart meters, that's a whole pain point, which we shouldn't really be doing. And I think there's an interesting dynamic around that. If those radios were software defined, perhaps we could update the software in the radio to respond to newer technology generations without having to do a truck roll or a hardware replacement cycle.
Thank you for sharing that. Thank you, everybody on this podcast. This has been a great conversation. It occurs to me that we probably, despite us talking for so long, haven't hit everything and we've only scratched the surface. But we covered so much ground today. I just want to thank each of you for joining us. And before we go, since this was such a big conversation, I want to turn it back to each of you. Just one final thought, a key takeaway that you want listeners to really get out of this conversation.
I think the first thing I'd just say is a lot more in the report that we haven't even touched on here. So definitely have a look at the report. It's all modular. It's all modularized to make it easy to digest. But I think the bigger piece here is that there is transformation happening throughout the grid. And we're in the middle of a period of quite rapid change. We're not at the end of it. We're not at the start. We're right in the middle. And this is something which is strategic for this industry, but this industry is critical for so many other industries. We've talked about, I think, about data centers and about the AI there. We've talked, I think, about the electrification of other parts of the economy, perhaps, steel furnaces using electricity rather than coal for that. I mean, there's so many different areas this touches on that I think this is fascinating, I'd say. But have a look at the report. Lots more in it.
And of course, the report is available in insight.tech, so I'll make sure to link it in the description for everybody to access it easily.
Yes, I would like to speak to the ones who are making the change, meaning the transmission and distribution grid operators, and we are all serving this. And these points are valid for hardware, software, and services suppliers. One, you are the key enablers of energy transition. Without you, without electric grids, no energy transition is possible. Secondly, you need to move fast forward. Definitely to accelerate, and you are on the way to accelerate when we see the investment planning of all the players. But for that, you need to get a consistent roadmap, revised every period of time, and to secure all benefits of all projects at all steps to monitor and secure these benefits. You need to avoid, when possible, grid expansion by digital technologies. You need to joint standards, E4S and other alliances, for effort sharing and for investment reduction?
Yeah, I would echo what Philippe has said, and just to say that when we talk about our involvement in the grid business as a hardware manufacturer, when I talk internally, I talk about a marathon and not a sprint, because it's going to take considerable amount of time to achieve things. But I think we're now at a point where, to Philippe's point, we need to accelerate, and the way to accelerate is through direction and priorities. And the alliances are working to give us some of that for sure. But I think to really get clear direction and priorities, we need way more of the people who run the grid, the DSOs, like Enedis and all the other ones to come join and help us on the journey, because even though we have some of the biggest players in Europe in the alliances and some in the world, we need everybody buying in. So it's really important, and we need to accelerate for sure. And that's my objective within Advantech, is to do the same within our product groups and within the business in general, as a focus on energy and utilities. Yeah.
First, I will summarize that digital end-to-end architecture for the grid is the best way to optimize all the investment, CapEx and OpEx that are going to be in front of them along the life cycle, from the design, simulation, build, operate, and maintain, thanks to all the new software analytics layer that are available right now. About basically what is key to make that happen. Standardization, we mentioned it, but it's essential. Having a unified open approach is vital for making that modernization in journey efficient. Leveraging successes of digitization of other sectors and their insight and their learning is very valuable in this journey. And finally, collaboration is key. We have to unite, the OT companies, the IT companies, the end users, the different experience into one group. E4S is perfect for that as a body, to ensure that we take all the knowledge from the different perspective and build the smarter grid of the future.
Great. And last but not least, Marc from Enedis, what can you leave us with today?
It has been very well summarized by my colleagues, and I don't want to repeat. But to conclude, I would say that we have in front of us a long and challenging and amazing journey.
Absolutely. And I can't wait to see what all of you do in this space, how the E4S Alliance standardize things, and just the continuing journey that we are on. So I want to thank each of you again for joining the podcast, as well as all of our listeners for tuning in. It has been quite a conversation, and I would say visit insight.tech, where we continue these conversations, continue to cover the partners here on the podcast. So thank you all again. Until next time, this has been the Insight.Tech Talk.